Chapter 1 Functions and Applications. Section 1.2 Functions and Model. Mathematical modeling. To mathematically model a situation means to represent it in mathematical terms. Mathematical models do not always represent a situation perfectly. Some represent a situation only approximately, whereas others represent only some aspects of the situation. So here we will do few examples about mathematical modeling. So suppose you have a situation where the temperature is right now 10 degree and the temperature is increasing by 20 per hour. How do you model such a situation? Simply, you say the temperature at time t is going to be equal to 10, which is the constant temperature, plus 20 times t. Capital T stands for temperature and lowercase t stands for time in hours. Likewise, we can also represent a situation like if you have 1,000 US dollars that you would like to invest in a certain bank, and the bank have a compound interest of 5%. How do you find the model that represent the compound interest? So simply you substitute in compound interest formula and you will get a of t is equal to 1000 times 1 plus 0.05 over 4 raised to the power 4t. That's the model. Also, if you are fencing a rectangular area whose perimeter is 100 feet and you are asked to find a function of the function that represent that or the function area, or find the area of a function of the width x. So simply you solve for y become 50 minus x, and then y being your length, so you multiply the length times the width, and that give you x times 50 minus x. Cost, revenue, and profit functions. A cost function specifies the cost C as a function of the number of items and has the form cost is equal to variable cost plus fixed cost, where the variable cost is a function of x and the fixed cost is a constant. Cost function, when we write it in mathematical terms, C of x is equal to mx plus b, where mx is the variable cost and b is the fixed cost. The slope m, which is the marginal cost that measure the increment cost per item, this is changing, while b doesn't change, it's constant. Rx, so let's say Rx is the revenue from selling X item at a price $m. So then the revenue function mathematically would be equal to M, which is the price of an item, times X. X is the number of items you are selling. The profit function, or the profit from any business, would be equal to revenue minus cost. So if you have revenue, you subtract off the cost, that what remains is your profit, and we can write that mathematically as P of x is equal to Rx minus C of x. Example 1. As of August 2010, Yellow Cab Chicago's rate amounted to $2.05 on entering the cab, plus 1.80 or $8.80 for each mile you travel. Find the cost function C for an X mile trip. Use your answer to calculate the cost of a 40-mile trip. What is the cost of the second mile? What is the cost of the 10th mile? Solution of example 1. The cost of an X mile trip is given by the linear function c of x is equal to 1.80x plus 2.05. So the cost function, as you can see here, is equal to variable cost plus the fixed cost. To calculate the cost of a 40-mile trip, simply you substitute for x equal to 40 and you do the calculation, and you will get C of 40 is equal to 74.05. So 0.05, if we ignore it, we just get $74. To calculate the cost of the second mile, we should first find the cost of 1 mile. The cost of 1 mile is $3.85, and the cost of 2 miles is equal to $5.65. Then the cost of the second mile would be so the cost of the second mile would be 5.65 minus 3.85 is equal to 1.80. And this in the same way, or in the same fashion, you can also find the cost of the 10th mile, which is also going to be 1.8. Example 2. The annual operating cost of eSport Fitness Gym is estimated to be C of x is equal to 100,000 plus 160 minus 0.2 x squared dollars. X varies between 0 and 400, where X is the number of members. Okay, annual revenue from membership is averages 800 per member. What is the fixed cost? What is the profit function? How many members must eSport have to make a profit? What will happen if it has fewer members, if it has more members? Solution of example 2, variable cost. So when we go back to cost function, we will find the part of it that has variable. We call that the variable cost. So it becomes 160 minus 0.2 x squared, while the part of the cost function that is constant is 100,000. Also, to find the revenue, we multiply the membership price times the number of members. The number of members is x, so then R of x is equal to 800 times x. The profit. To get the profit function, we say profit function is equal to Rx minus Cx, and that is equal to 800x minus the whole cost function, which is 100,000 plus 160 minus 0.2 x squared. Okay, now let's assume that at the break even, usually at the break even point, the profit is 0. So we set the whole profit function into 0, and then we solve for x using the quadratic formula. So then x is equal to 149, x is equal to negative 3 349.3. This one would be rejected because we cannot have negative members, but x equal to 149 is accepted. To make profit, the company should have at least 150 members. It can have 300, it can have more, but it can never have less than 149. If it has less than 149, it is going to lose. Supply, demand, and equilibrium price. A demand equation or demand function expresses demand Q, the number of items demanded, as a function of unit price P. A supply equation or supply function expresses supply Q, the number of items a supply is willing to make available, as a function of the unit price. It is usually the case that demand decreases and supply increases as the unit price increases. Demand and supply are said to be in equilibrium when demand equals supply. The demand curve usually has a negative slope, while the supply curve has a positive slope. And usually when the price of an item is very small, the quantity demanded becomes very big. When the price of an item becomes very large, the quantity demanded becomes very, very small. Unlike the supply, so the supply, whenever the price of an item is big, the supply of that item also becomes bigger. When the price of an item becomes very small, the quantity supply becomes also very small. Example 3. The demand for private schools in Michigan depends on the tuition cost and can be approximated by Q equal to 77.8 times P into negative 0.11, where P is between 200 and 2200. P is the net tuition cost in dollars. What is the effect on demand if the tuition cost increased from 1000 to 1500? So when we plug in 1000 into the demand equation, we get 36,400, and when we plug 1500 into the demand equation, we find 34,800. The change in demand is equal to 1,600 students. So you can observe here, when we increase the price, the quantity demanded decreases, and when the price was 1,000, we get 36,000. When the price become 1,500, now it become 34,000. So there is decrease, and the decrease of the number of students here is about 1,600 students. So quick example: if demand for your exclusive shirts is equal, Q is equal to negative 20p plus 800 sold per day, and the supply is Q equal to 10p minus 100 shirts per day, then the equilibrium point is obtained when supply equals to demand. We are interested in finding the equilibrium, so we equate the quantity demanded must be equal to quantity supplied in the equilibrium point. So when we solve these two equations simultaneously, we find P to be equal to $30, which is the equilibrium price. So example 4 here, I have two different equation, the demand equation, just like the previous example, and then a new equation, which is the supply equation. Q is equal to 30.4 plus 0.006 P. This is in thousands. So right now I want to answer this question: what happens if the tuition is higher than the equilibrium price? what happens if it is lower. Estimate shortage or surplus of opening at private school if the tuition is set at 1.2. Alright. Solution. We can find price value for solving by solving two equations. So when we solve the two equations together, we can find the equilibrium price, which is right now 1000. If the tuition charge is higher than the equilibrium price, there is a surplus in seats. If the tuition charge is lower than the equilibrium price, there is shortage in seats. So graph of the solution. So the graph of the solution is depicted here, and you can see here the equilibrium is exactly at 1000. So alright.